Good afternoon, everybody. My name's Richard Hanson-Graville. I'm the Head of Research and Development at Thermal Integration. We're a manufacturer of heating equipment, going back to the 80s. One of the first companies to put plate heat exchangers onto cylinders, create thermal storage technology, advanced a lot of the stuff that's going on in communal heating and district heating. We recently won a competition with UK Innovate to open source heating controls in the industry. So as a manufacturer, we've got a track record of delivering equipment that runs to the highest quality, but it's always been done behind closed doors in the HVAC world, with a general consensus being to lock stuff down, charge for any visibility, hide mistakes, which is one of the driving reasons why a lot of the heat networks and equipment out there at the moment just doesn't work and is terribly inefficient, and is the driver for all of the H&S schemes the government are putting out to fix these things. So our basic principle is improving control, increasing transparency to get to greater efficiency. Basically by bringing the existing open source technologies to the heating industry, rather than try to reinvent the wheel from scratch. It's basically assemble what's out there as efficiently as possible and get it to a level which is OEM ready. So it's a proper tool to actually use in the industry, coming from the inside out rather than the outside in. So we're coming from, as a manufacturer, an existing control systems which go into kind of combi boiler kind of equipment that you'll see in your property. Also, though, it goes into larger heat networks and heating systems. So just to give you an idea, we've got various things. You know, you've got pumps in plant rooms, you've got boilers, buffer stores, things called HIUs in properties. So all of these different parts in a heat network have to run efficiently. You have to be able to see them, commission them, and they have to comply to the latest regulations. But general rule is you can't see, they're all invisible. The recent studies we did under government, I think we did about 11 of them, and not one of the heat networks came even close to working. The one thing that we found that was missing from the industry is an open source bit of hardware. So we've got technologies like Raspberry Pis, ESPs, but what was missing was the actual I/O board to give us the dedicated I/O we needed, which was things like M-bus for heat metering, PWM in and outs for pump control for solar applications, RS485 for your Modbus connections, battery backup is a big thing in the plumbing world. If you lose power, you need to shut valves, which is often a function missing. So we've effectively designed an I/O board which is suitable for us to use in our own equipment, it's cutting edge, it does all of the functions you'd expect, and then some. We've designed it to be fairly hardware agnostic as far as the controllers go. So we've worked historically with the Raspberry Pi for 15 odd years, Arduinos and all this lot. So we've settled on the compute modules as a sort of more robust industrial version of the Raspberry Pi. And we've also got it to work with ESP32 boards, Beagle bones. It's an I2C driven board with open source libraries. So that the board can be taken and pretty much adapted to any control system. So as part of the funded project, we've also gone into enclosure design, getting the tooling done for a decent enclosure. So you can take a Raspberry Pi, an ESP32, mount the board on it, put it in an enclosure, and you've got a fully ready to roll control system for domestic or industrial use. We've got there's a few other things. So we're not trying to say everyone use this I/O board. That's not what we're doing. We're trying to solve problems out there in the real world. So that means taking on and making use of just about every bit of hardware that's out there that's actually reliable enough. So there isn't much of it, but there are certain boards which are, over the years you learn. So there are various boards. This is a particular one from SOOCon Microsystems that's got a nice. It does a lot of temperature sensing and 0 to 10 volt control, which is perfect for 80% of HVAC applications. It's got one wire, and we can always add a few other functions to it. And it's got the RS485 as well, which is very handy. In the field, though, most people don't want to be playing around with control systems. They want to walk into a plant room, just stick something to the wall, wire cables into it and be done. So we've developed a range of various application enclosures. So it's like the board in a box, but it will be pre-wired to a solar controller system. So these are just sort of little ways of making standard applications. This is the highest level we do, so we put them into control panels. So what you see here is a control panel running the red brick estates for Islington Council. So that's looking at all of there's about 200 properties, putting all the data down, it's doing alarming, energy monitoring, it's checking the functions of the plant room, reporting alarms. So this is an entirely open source system, contract license free for life. It's probably about 1/10 of the cost of the BMS system that went in there that doesn't work and doesn't show you anything. So this is the technology, and this is what's actually fixing problems out there. You know, in a matter of days, we can walk in, gain visibility and transparency on networks that have been in the news for 10 years, and actually fix some problems. Because that's a lot of the problem in this world. It's effectively not being able to see what's going on for various political reasons. Other sort of stuff, well, we're doing a lot of, we want to get in and out on a lot of missions to find stuff out. So we've pulled into it the Ian Ocean range of wireless stuff. We've mucked around with quite a few different wireless systems, but the Ian Ocean, in the plumbing world, having something that doesn't need to change batteries is kind of important. So these are energy harvesting devices. So from a HVAC point of view, they work very solid, they go in, they're robust, and we don't have to worry about battery use on them. Okay, another bit that seems to be missing is the actual wiring. So we're getting into here. There's a lot of people here at this conference today live in the data world, but as soon as you hit the plumbing world, you start getting into the wires, the mechanics, the hydraulics. That's where the expertise is required, and that's where there is very, very little. So we've written applications that are on a website where you can drag and drop various sensors from pallets. We've worked with manufacturers, Sonte and Grundfos and the like. So if you drag a pump on, it's preloaded with the NTC charts or the Modbus data tables. It just drops onto the canvas, it will automatically wire it up. So if you're completely uninitiated in the electronics or BMS software world, you can effectively say, I want 3 sensors, drag them on. It gives you the wiring diagram, you go away, wire it up. You download the code it gives you, and Bob's your uncle, all the data appears on a Grafana dashboard. So we're really trying to sort of cut out all that middle expertise. It's not really expertise, it's just the groundwork of wiring diagrams. The expertise is in the plumbing hydraulic layouts. That's another thing. Okay, so to do this, we've been trying to make these things license-free for life, so we can actually fix these big problems out there without a barrier. If there's a cost to visibility, that means you stop at a certain point when the budget says that's how much we can get, which means you never get all the extra visibility that you need for the fine-tuning, the refining. So it's only with license-free monitoring that you actually get the data you need to get these things to zero carbon. So we've adopted, everyone will recognise certain names, Docker systems we've built in as a way of sort of standardising some of the application installations. Node-RED, we've been running with this Node-RED now for about 15 years. So we use this for the control side. We're not just talking monitoring, we're talking control. So, for example, the substations that run all of Clapham for Pinnacle Power run on that, they're all Node-RED driven, all the logic's Node-RED driven. They've been out there for 5 years now doing the thing. It's a superior control system to the various control systems you have in the BMS world. So effectively Node-RED we can do in days what takes you months and months of pulling teeth to get done on a traditional kind of BMS system. MQTT we're using for main communications, sharing between points for obvious reasons. Now visualization, this is the bit everyone sees. It's the top layer of the skin. But in some aspects it's the most important bit. I mean, the important bit is what it's showing you. We spent about 10 years developing visualization systems, which are pretty close to Grafana, if you've heard of it. You know, animated SVGs, graphs, and this lot. So we came across Grafana about 6 months ago, and it became very clear very quickly this point was trying to work in an R silo against a system like that. So we've fully integrated Grafana now as the front-end visualization system. with influx database as the standard time series database. So everything comes out of control systems into an influx database, and then it's run on Grafana. And these will run in the controllers themselves as standalone entities for domestics or in a council. You'd be running this on your cloud systems. Okay, so this is a typical Grafana looks like for a site in Putney, a few tower blocks. This is a site that's gone for 10 years. It's never worked. Every Christmas the boilers fall over. They've never been able to see what's going on in the plant room. So we won't spend a day or so in the plant room connecting sensors to the existing equipment, sucking some data out of heat exchangers, pushing it all up to Grafana. So this Christmas was the first Christmas they went through where the actual mistakes could have been spotted, they could be fixed. So they had a hot Christmas this year, and we've been able to spot a lot of other problems. The heat pumps on the roof were never wired up 10 years. The extractor fans on the block suck all the heat out of the building, we found. They go from maximum to minimum. There's never any modulation. So the residents have actually got access to this system, and it's the residents that have driven the works. So you've always got this layer of management in the middle that's more profit-driven and doesn't really, not suffering. Whereas the residents, they live with the problems, but they never have a way of seeing the problems. They know them, but this has effectively given residents the ability. And you always get a few residents in this side who are very technical, engage with the systems, and it's been very positive. We've driven things forwards. We've been able to tell the installers what they need to do next based on data each time. So there's no money wasted on dodgy fixes, which is what they've been going through for 10 years. So this site is coming along very nicely. We decided to do quite a few field trials in the project because this is quite an evolved system. We've been developing it for 5 to 10 years, and the funding effectively allowed us to get it into place as a proper project, open source. So we were able to take on quite a few field trials, but they include the Barbican Centre, the Excel Centre, Morden Hall, which was the flagship BREEAM Renewables site for the National Trust, Swansea University, Solar Heat Energy Demonstrator Unit. We're running up the world's first CO2 heat pump system running a heat network because we have a control system now. We can do this sort of stuff on, and we can partner with academia on these kind of research projects, which you can't do in the heating world. So one of the applications that we were asked to nail down certain applications. It's quite a general purpose field, HVAC. So we focused on 3. It can kind of do anything, but so the first one was this thing here called an HIU, monitoring and control. An HIU is a hydraulic interface unit, but it's basically a boiler, combi boiler, that runs off a communal heating system rather than gas. So these are what are coming in, these are what you see in all the council estates, blocks going up these days everywhere. So we've built the latest generation of HIU using the control system, which is what we originally got it made for our in-house products as an OEM. So this is an HIU running a care home in North London. It went in, the installers made a mistake with the installation. We spotted the mistake before the installers did. When they phoned us up, they had a problem. Our engineers were already on the way to the site. It was fixed before the residents even noticed anything. So it's a perfect example of how you can use the data to spot the mistakes and get to them, alarm them, take the guesswork out of it all. The other one is fan call monitoring. So there's a lot of big fan calls everywhere. It tends to be a sort of art place very few people go and look at. Be amazed how much energy is lost through inefficient fan call systems. So we went in to look at fan call units. Probably the most interesting ones we're working on are the Excel Centre. So that's the Excel Centre N1 exhibition halls. That's us up in the top left, starting to put sensors onto the air handling units. So we found that the existing systems didn't show half of the data. They were simplified of the actual problems that are causing the inefficiencies. So the Excel is driven by heat networks supplied by ENGIE or Equans now. So they wanted first they want to improve the efficiencies in the hall because the air handling units are wasting energy, and also to get temperature drops so the ENGIE heat network would work efficiently. So this is it. So we're putting data onto Grafana. That's showing us what's going wrong with the systems. That allows us to then go in and do some targeted works and proper save some energy. Buffer store control is the other application, which is basically controlling boilers, heat sources. So you have a hot water cylinder at the centre of it all, and you need to control the bits that go in and out. So buffer store control is a common function. This also covers domestic solar cylinders, wood burner systems. So if you want to combine a wood burner with solar thermal to do radiators and hot water, that's a buffer store control function. So there's a few other bonus things we've done in it. Obviously, we've got the platform here for doing wireless monitoring, so it's made its way into a few domestic properties, so we can just sort of get feels on CO2, temperature and humidity throughout the day. So it's a bit like smart metering, but using actual graphs, so you can analyse the data over historically. So there's nothing really clever or new in this, it's just the system exists there, so we've naturally covered that off. Okay. So this and the other one is the CO2 heat pump. So this is going a bit off piece, but this is a technology we've been trying to get into the HVAC industry for about 10 years or so. So we've had them going in the domestic world. In the heating world, you have consultants with professional indemnity, so they can't do anything that's not covered by regulations. We sit in a little sort of unique spot because we write the regulations. So we wrote the CP1 guidance for heat networks. We wrote the original plumbing guidance for the Institute of Plumbing. So we're in a sort of technical position to take on these jobs, but the only way this job happens was with partnering with a university. So there's no consultants in the picture. We've designed a system to run a CO2 heat pump, which should allow us to get the cost of converting, retrofitting existing housing stocks to about £5,000 a property. That's a schematic. So this is where the expertise comes in. So it's the hydraulic systems behind the plumbing system. So this is a brand new arrangement which kind of follows all the latest guidance, but because it's new, CO2 heat pumps aren't warranted. If this all works, it should be going live in about 3 weeks. Mitsubishi Electric will start hopefully warranting CO2 heat pumps for use in heat networks. And then we're away. So we are focused really on business to business initially, because that's where, well, for example, one of the fan cool units we found was cooling and heating at the same time. So it was putting in 220 kilowatts of heat and 210 kilowatts of cooling on and off all day long, every day for years. That's 100 houses worth of energy, literally just wasted in a single commercial air handling unit. So business to business is our initial focus, but obviously we need to engage with the public. So we're starting off with a discourse forum to try and isolate ourselves a certain degree and use the open source project so people can learn from what we're doing in the field. They can buy a Raspberry Pi, they can start having a go in their own properties. And we use the discourse forum as a way of sharing the information, disseminating field trials, and doing this so it's not over the phone in inquiries, it's done in public so everyone can learn and treat it as a bit more project. Okay, and out of the projects really the sort of things that we're doing, which is it's plumbing expertise oriented, so that's our forte. So there's a lot of people want to getting into the data levels of building performance, but they hit this mile where they need to talk to someone that can actually look at a schematic diagram, knows the regulations inside out, knows what what pipe needs connecting to what pipe. So that's where we fit in. Wireless sensing, data bridging, OEM consultancy, this kind of thing. We're doing a lot of the schemes for the government on the new AgeNES. Okay, so that's what we're up to. Thank you very much for listening to me. If anyone has any questions,
Thank you, Richard. We do have one question here.
Yeah, I was just going to ask where people are sort of doing this in domestic properties. I'd sort of looked at this a little bit, and one of my friends raised a problem that I wondered whether you've managed to deal with, is what effect does it have on your home insurance when you're messing around with your heating system like that?
Right, well, messing around with the heating system itself is different to monitoring the heating system.
Okay.
So for a domestic property, there's these things like turn your stat down a degree, which is a really, really, basic level sort of stuff. Mm-hmm. What we do on domestic properties is the biggest energy savings are actually to do with adjusting your heating temperatures. But it's working out the optimum temperatures, and you need to change it based on the outside air temperature. You don't just fix it at one thing and leave it. It's a case of you need adjusting. So you can monitor the pipes, you can monitor the outside air temperature, and it can tell you. So you're not interfering with the mechanics. at all. The next level is where you need to get into mechanics, which is kind of where we do help come in, because we're all fully qualified plumbers and engineers, and so when you need to get in and actually breach things to put pressure sensors in.
Yep.
Pressure sensors is an obvious one. Sure. Then you get into controlling boiler set points. Then yes, you do need to have someone who's qualified to install something like that. Yep. But the idea is to get the data in the first place to know what's going to be most efficient and to give you a feel for it. Okay. And to say we've got a magic bullet that you install and it works it all out for you, that's not how it works.
Yeah.
Please.
Lots of ways that you've avoided energy wastage. You've articulated some of that in your presentation. Do you have any numbers for the specific projects of we've saved this much energy or this many kilowatt hours, and do you publish them?
No. The one particular air handling unit that we talked about, we have figures on there. We have graphs because monitored data on it. So we know that particular air handling unit in one space was 400 kilowatts. We do have monitored data from a lot of the field trials, but they're only just start. Like the Excel is just last week. It's come live. The shed isn't live yet. So we do have data. The Energy Saving Trust are probably the only one that's been fully open with the data, and they kind of said, well, let's everyone learn from our mistakes of the past, rather than let's most general people want to hide the mistakes, maybe fix them. So we do have some data, and we will have a lot more as time progresses from the field trials, because they're now just spitting out loads of data. Yeah, no, there's not too much, because most people are still very protective. There's often residents who, if they found out what was going on, they'd be held to play. So it is a bit of a bit of a minefield in the open world, what you show and what clients show, and it's a bit of a mission with clients to sort of get them to engage that openness is the best. The heat dies down with residents once residents know you're being open and following. So there is data, but yeah, there should be a lot more of it, and hopefully there will be as people learn as time goes on, yeah.
Yeah, we have another question there, please.
Hi, AV Walls with Viva City. We actually have a very similar product to you. We're using hardware sensors to provide data where there were none before. We work with local councils to provide traffic data, and something we are finding is that the incumbents are really not wanting to work with us because they see us coming along. Yeah. Is this something you've been experiencing?
Yes, we're slightly different because we're from the inside the industry, so we're a manufacturer, so we have to deal with all the main contractors, the Barretts, the Wimpeys, the Langholms out there. Yes, everyone makes a huge amount of money in the world out of BMS systems. There's a massive barrier. Nobody wants open source or anything getting near these places because it kind of destroys the two business models, which is one, do it on the cheap and hide the fact that you've done it on the cheap, and two, charge them for the bit system that's meant to be showing you, but it doesn't show you. So there is a lot of resistance. There's very few companies out there in the heating world that installers that have engaged with openness. Very, very few. And I think that'll be... You've got to remember, coming from a point where the plumbing regulations were wrong. They were only fixed 2 years ago. So we've got 10 years of pipes being 3 times bigger than they should. So the whole industry is in defensive mode at the moment. No one wants to stick their head up, and it will come with time. But you look at an industry here that's effectively Grenfell. You know, they think the plumbing's any better than the cladding. No, it's worse. That's the sort of scenario that we're in, as I'm sure you're feeling.
We have one more question here.
Thank you very much. I've got 2 questions, but they're fairly short ones. So the first one just reveals my ignorance here. You were talking earlier, this is just sort of intriguing about the technology, you were talking earlier about the sensors being battery-free, and I think you said they're energy harvesting, and I'm just intrigued to know how that works.
Solar cells, Peltier modules.
Yeah. Sort of thermocouple.
Basically the air and ocean range of stuff was the reason. Well, we've tried it all around the lot, but the air and ocean stuff, it's energy harvesting. That was the first thing. So you, depending on the application, there's usually one of the 3 methods. It's mechanical, solar, and heat to pull the heat. So, and it's also a solid wireless system. So they actually drop in and work. Oh, okay. First time, put them in, press a button, it pairs. Wow, that took me 3 days to not get that far with a LoRaWAN system. So. Yeah. Yeah, it's just allowed us, we ran with it, and it hasn't snagged us once yet, and it's been a pleasure to work with so far, which is quite rare with wireless stuff.
Yeah, no, that's great. Thank you. The other question is, as far as the open hardware and open source software components are concerned, what's the licensing model for those?
Apache 2. So everything we're doing, we're putting through Apache 2. So that's the hardware, circuit hardware designs, and all of the software that runs on the Pi side of things. There will be proprietary stuff when we get into plumbing rooms, so when we work out how a boiler should be cycled, there's obviously a world there that you need to protect. But all of the system, everything's Apache 2 as open as we can be. All the field trial software and all that's out there, on that.
Great, thank you very much.
We still have time for one question. Yes. Two.
Hello. Really silly, deeply focused technical question. What type of real-time clock modules are you using?
I couldn't tell you. The actual chip on the real-time clock modules. No, there is a real-time clock on the board.
Okay.
Yeah, I couldn't tell you off the top of my head what module is for that.
Okie doke.
Please.
Yeah, so you mentioned your code's Apache 2, but you also used in the presentation a few times the phrase license-free, and I would just suggest maybe you might want to be careful around that wording.
Yes, there's some terminology, yes.
Yeah,
with
open
learning.
source is very carefully licensed, and obviously your code, you've said, is licensed Apache 2, so you just... Otherwise, everything else sounds amazing.
We're in a sort of clash of worlds, coming from the heating world, where people talk about licenses, they mean something very distinct.
Right.
Paid for licenses, yes, that's kind of the term, and as we're learning with events like this, coming from the HVAC world, yeah, completely agree with you.
Okay. Hi, thanks for the presentation. I've got quite a general question. I wonder if you could comment on it as to when you're building these sort of like appliances for residential or industrial purposes, what the sort of additional safety and security considerations when using things, like depending on the different thing you're using, you might have different attack surfaces, like, Raspberry Pi being probably a Linux thing. You got those things, and ESP probably less considerations as well. But I was wondering if you could just comment in terms of your overall strategy and how you see how that thing can be developed in an open source way.
Yeah, so it's ongoing, the security side, and we're developing it from events like this and partnering up with people. We generally lock everything down. We try to stick to one external communication like an MQTT port. One of the funny things is in this world is if you take 20 heat networks, none of them will work. There are two attack vectors. One is incompetence, one is the Russians. I've never seen a heat network not work because of the Russians. That's the reality.
Sorry, final one just along the lines of that is when you're doing the Raspberry Pi, what type of operating system would you be running that? Are you doing like a BSD or a Linux?
We're on just the standard Raspberry at the moment. We're looking at porting it to, is it a Yocto image?
Okay.
Yeah, so it's a bit more industrialised. So that's a new journey for us. So we've just employed a guy, it's part-time, that lives in that world, that's done it for medical equipment. So we're coming from the application and get it working, get the plumbing fixed, and bang, and then it's refined, then it's engaged with another community, your communities, for example, to help us refine the actual, that side of it, or once we've shown that we can save some serious carbon.
Great, thank you.
Thank you, Richard. So sadly, we do not have any more time for questions. Thank you so much, Richard.